Welcome to you all. This is KSOU MSc 4th semester syllabus, paper Inorganic Chemistry, Unit 2. The objectives of the units are to discuss the properties of a group, abelian and non-abelian group, order of a group, group generating elements, subgroups, class of a group, some important note on classes, group multiplication tables for symmetric operations of simple molecules, isomorphism, the transformation classes, group multiplication tables, some important characteristics of a group multiplication table, symmetry classifications of molecules into point group, difference between point group and a space group, finally to summarize that unit. A subgroup is a group within another group. Simply that is called subset of group elements. A supergroup is a group obtained by adding new elements of a group to give a larger group. In order of many subgroup C of a group, order is H, that is written H by G. What we are getting, that is what it is K. A is said to be conjugate with B. If there exists any element of group X, A is equal to X bar B into X. Every element is conjugate with itself. A is conjugate with B, B is conjugate with A is conjugate with B and C, then B and C are conjugate with each other. These are the definitions of these word groups. Some properties of groups are mentioned here. The elements of all groups obey simple set rules. What are those rules here? The product of any two elements of a group must also be an element of the group. Consider here sigma V dash into sigma V, that is what C2. The product of elements are associative. Associative law, we know that. What is the simple basics of this associative law here? A into B into C is equal to A into B into C. That is what associative law. Here sigma V dash into sigma V into C2. Here sigma V dash into sigma V into C2. The group contains an element which multiply another element, leaves it unchanged. Such an element is called identity and represented by the letter is E or capital I. Here C2 star into E is equal to E star into C2 is equal to C2. Now each element of a group has inverse, which is also an identity of the group. In C3V group, C3 and C3 inverse are inverse of one another. Here C3 is equal to C3 inverse of one another, that is equal to what? E only. What are abelian and non-abelian group? And group is one in which all the elements commute with each. That is, for any two elements P and Q, P star into Q is equal to Q star into P. Here C2V group elements are E, C2, sigma V and sigma V star, sigma V dash. How it is written here? C2 into sigma V is equal to sigma V dash into sigma V star C2 is equal to sigma V star. Similarly, we consider here sigma V star sigma V dash equal to sigma V dash star sigma V, that is C2. What is this? C2V group and abelian group. There are only few abelian groups. What are those? Cn, Sn, CNN, C2V, D2 and D2H. These are all the example of this abelian group. Here D3H is not a abelian group. The properties of this element is do not obey. They are called what? Non-abelian group. What is order of a group? H. The order of the group is similarly the total number of elements in the group. That is what? Order of the group. The order of the group is similarly the total number of elements in the group. For example, in C2V group, the order is formed, there exist. There are some elements, namely E, C2, sigma V and sigma V dash. In C3V, there are 6 elements. We consider here E, C3, sigma y dash, sigma y double dash. Therefore, here the ordering C3V is 6. The group generating elements. In a group, there will be a small minimum number of elements is called a subset. The elements of this subset are called group generating elements or group generators. These groups generators can generate all the elements of the group. For example, C3 group has the elements E1, C3 dash, C3 twice, C3 dash. These are all what? Group generate. Here C3 star C3 twice, what it becomes here? C3 2. This is all are here same. If same, what we are getting? Identity only. In C2V group, sigma V and sigma V dash are group generator elements. We consider sigma V star sigma V. What is that identity? Sigma V and C2, that is sigma V into identity, that is what? C2. D3H has 12 elements of symmetry. What are those 12 elements? E, C3 dash, C32, C2, C2 dash, C2 double dash, sigma V dash, sigma V double dash, sigma N. Next, S3 dash and S3 5. These 12 elements belongs to in that D3H. The group generating elements are C3 dash, C2 perpendicular to C3 dash and sigma N. Now we are going to discuss with what is subgroup. The smaller groups which can be found within a bigger group are called subgroups. The subgroups must obey all the conditions to be called a group. There are two types of subgroups. They are trivial subgroup, in which there is only one element E and the other of this group is 1. Non-trivial subgroups, in which element E is invariably present and order of these groups begin with 2. In the order of the subgroup is Z, that of full group is H, then H by Z is equal to K. K is an integer. Consider some of the example of these subgroups. C1 group has no subgroup, it has only one element. C2V has trivial subgroups E and more subgroups. Here C2 is equal to here E into C2. C2 is equal to E sigma V, and here delta C dash gives here identity into sigma V dash. The C3V elements exist 6 subgroups. Here C1 to E, G1 H by G is 6, C3 3 to 2, delta S, Z2, H by Z3, and E into sigma V dash, G value is 2, H by Z is 3, CH double bond here, E into sigma V double dash, G is 2, H by G is 3. What we say that here all subgroups contains the element E. The element of a full group may or may not commute, but elements of this group of subgroups do necessarily commute. Therefore, subgroups are always abelian. What are the class of a group? We have already seen how it is possible to select set of elements constituting subgroups. There are another way of sorting out elements of a subgroup into what is called classes in order to understand how to rearrange elements into classes, we need to know how new operation is called, that is called what? Symmetry confirmation. We consider elements like A and B or classes of group X is another elements of the same groups such that X dash A into X, that is what B, because X is inverse of X, we are getting cancelled. The product B is called similarly transform of A by X. A and B are called the conjugate elements. The following three elements is conjugate elements. Every element is conjugate with itself. X dash A into X is equal to A. If A is conjugate with B, then B is conjugate with A inverse AX is equal to B. B is the similarity transform of A by X. Also, there must be an element Y in the group such that Y inverse B into Y is equal to A. A is called similarity transforms of B and Y. If A is conjugate with B and C, then B and C conjugate with each other. What happened here? X inverse AX is equal to B, Y inverse AY is equal to C, then X inverse BX is equal to C. What happened? That is equal to B1. A classes of group is now defined as a set of elements which are conjugated to another. That is what? A class of group. Here just we see that similarity transforms of each of the above 6 elements with every other element. Also use the group multiplication table C3b group to work out the product of similarity transformation. Send sigma v dash, sigma v double dash are their own inverse and C3 dash and C3 square are the inverse of each other. Similarity transformations can be written on E identity. Just to see here, E into E into E, what we are getting E, C3 square, E into C3 power 1, E, C3 power 1, E, C3 square, sigma V, E, sigma V, it is only identity, sigma V dash into E into sigma V dash, that is E, double dash is also. In all these transformation, E has come out as its own similarity transformation. That is, E is self-conjugate. Therefore, the conclusion from this exercise is that E is the class by itself and the order of this class is always 1. Irrespective of the point group, it belongs to 2. This class is called a trivial class. The similar transformation C3 dash and C3 square can be worked out as a given below. These are all other set of these. Just to go through that. Similarly, only from these two exercises, it is clear that C3 dash and C3 squares are mutually conjugate, hence they can be in one class. In order of this class 2, we can similarly work through the exercises for sigma v dash, sigma v double dash, but the product transformations will not be that strength format. This other set of this. All planes like sigma v dash, sigma v double dash are in one class of order 3. While working out of the similarity transformations on one of these planes, say sigma v, if the product transformations occur as sigma v dash, sigma v double dash, then it is not really necessary to carry throughout the exercise in sigma dash and sigma v double dash. By resource to property of associative conjugation, one can conclude that the three planes can be put into one class. Like that, sigma v plane and its two product transforms, sigma v and sigma v double dash. We can adopt from these two methods to following that the use group multiplication tables and use of molecular geometry for figurative illustrations as shown below. It is rather easy to visualize the transforms of C3 dash and C3 square and sigma v dash and sigma v double dash planes, the transformation such as like that. Here E sigma v into E sigma v class is same class what we are getting. What are the important note on classes? A perusal of all the point groups reveals that there are only 6 groups of abelian groups, all other are non-abelian. Based on this information, we can further state in all abelian point groups, each element is in a class by itself. The number of symmetry elements of order the group is equal to number of classes. In non-abelian groups, the number of classes is always less than the order of a group. No element of the group occurs in more than one class. What are some hints on classes? E is always in a class by itself. E means transferred into itself by all the elements of the group. Inversion elements I is in a class by itself. All Cn M axes are in a class. C2s are in a one class. Sn axis like Cn axis are all class. If there are two or more, many such types they are placed in and many classes. Similar vertical plane and similar dihedral planes are in separate classes. Horizontal plane is a special plane is always placed in different class from other planes. How to group multiplication tables for symmetry operation? of simple molecules. Here first we have to construct the group multiplication table represents all possible productions of elements of a group. The form table. Consider a molecule having 8 symmetry elements. Then there will be H square products of symmetry elements. These can be presented as GMT, group multiplication table. It consists of 8 rows and 8 columns. Each row and each column is tabulated within a group element. The entry in the table, that row under a given column in a given row is product of element which headed that column and that row. Here what is that? Example C2, E, C2, this one. Here E into E is what? That is E only. E into C2, C2, E into sigma, sigma V, E into sigma V dash, that is same. C2 into E, that is C2. C2 into C2, that is C2 into E. C2 into sigma V, that is sigma V dash, like that. That is the constructions by using these datas. By using these datas. What is that? Classes of a group. Classes in a group. We construct the table. And sigma V into E, sigma V into C2, sigma V dash, sigma V into sigma V E, sigma V into sigma V dash, that is C2. Similarly, C4, E into E, E into C2, C2, sigma, C4 dash into C4 dash, what we are getting here, C2, C4 dash, the C4 1 into C4 3, what is that? Identity, like that. In this group, with its group multiplication is written either way of isomorphic only with an abstract group Z to 4 of the same order consisting of E, A, B, C elements. The one to other correlation of their elements such as A to C, B to C4 dash, C to C4 3. Like A of Z to 4, C2 is its own inverse. C4 and C4 3 have no inverse of each other. In March, the same way as to do B and C. Similarly, S4 groups like C4 can also be shown as important with Z4. The GMT of S4 group is given as. This for H4 molecule into E into C2 into S4 into S4 3, almost similar with identity elements. Here G4 1, since each element ABC or its own inverse and above mentioned 1-to-1 correlation of its element with those of Z2. We consider other thing, C2H molecule, it is undergo group construction table or group multiplication table. Similarly, C2V also. By considering these group multiplication tables as Above can be used with a lot of advantage for determining the product elements of similarity transformations. What is that isomorphism? Two groups are supposed to be isomorphic if they obey the following rules. Both have same order and structure. There is one-to-one correspondence in all the respects between the members of the two groups. Corresponding to, here A1 corresponding to A2, B1 corresponding to B2. Next, the relation between any two members of the groups is exactly same as the relationship between the corresponding members of the other groups. Let us take the three groups are listed below here: E into C2, E into CV, E into sigma H, E into C2, E into C2, E, and E is equal to I square, I is equal to I. These are all what different isomorphism. What are the similar transformations here? We consider like molecules here, ammonia is a similar. Here there is no changes here. The plane formed by z-axis of ammonia, this one. Plane formed by z-axis and ammonia HB. Plane formed by z-axis and NHC, this one. Let us prefer the designations sigma dash, sigma double dash, sigma triple dash. Let us perform a reflections with respect to the plane formed by NHC and z-axis. Let us perform sigma again, sigma triple dash square is equal to E. But we consider the following rules about conjugate elements notable. Every element is conjugate of itself because every element is the similarity transformation of itself with respect to identity. A is the conjugate of B, then B is the conjugate of A. This means that if A is the similarity transform of B, similarity transformation A by X inverse, then A is equal to X inverse B into X. It follows what associative laws. What are the classes of this group theory? A complete set of elements which are conjugate to another is called a class of the group. Let us consider ammonium molecule set as to coordinate system in such a manner that ZNH plane. Without disturbing the ammonium molecule, rotate the coordinate systems by 120 degree with respect to axis. Subject the coordinate systems to C3. Now YZ plane is NHYB. Sigma XY is sigma dash, sigma double dash, sigma triple dash are equivalent. Sigma becomes same as that of sigma if we change the coordinate system by symmetry operations of the point group. Sigma dash and sigma double dash are therefore in the same class. Generally, we discuss the reflections of this ammonium molecule constitute a class. It is not difficult to show that C3 square and C3. Let us perform that C3, this one. Both sigma and sigma dash are conjugate. Similarly, we can show that sigma dash, sigma double dash, sigma triple dash are mutually conjugate. Therefore, sigma dash, sigma double dash and sigma triple dash form a class. Now we are going to discuss with group multiplication table. Every group is characterized by a multiplication table. The relationship between the elements of the binary combination is reflected in the multiplication table. Consider a water molecule. It has four symmetry elements E, C2, sigma V and sigma V dash. We can easily show that the product any two symmetry element is one of the four elements of the group. Thus, intense C2 sigma V, sigma VZ. Now, presiding this way, the symmetry operation of water can be listed in a group multiplication table as shown below. This is what group multiplication table E into E, E into C2. There is no changes. What are the important characteristics of a group multiplication table? From this group multiplication table consists of H rows and H columns, where H is the order of the group. Each column and row is labeled with group element. The entry in the table under a given column along given row is the product of the element which had the of that row. At the intersections of the column labeled Y and row is labeled by X, we found the element with the product X and Y. Each following theorem holds good for every group multiplication table. Each row and each column in the table list each of the group elements once and only once. No two rows may be identical, nor any two columns be identical. Thus, each row and each column is rearranged list of the group elements. What are the symmetric classifications of molecules into a point group? Molecules can be classified into a point groups depending on the characteristics set of symmetry elements proposed by them. The molecular group is also called point group since all the elements of symmetry present in the molecule intersect at each column point, and this remains fixed under all the symmetry operations of the molecule. The symmetry groups of the molecule are denoted by specific symbols known as the Schoenflies notation. How to differentiate between that point group and a space group? Symmetry operations do not alter the energy of the molecule. Further, all the above operations the center of the molecule is not altered, as none of the operations involves a total translational movement of the molecule. However, it happens to the molecule, the center is not changed. At least one point is fixed, and these are classified as point groups operations. In case of crystal operations such as screw rotations and glide plane reflections can be additionally specified. Screw rotations involves a rotation with respect to an axis and then a translational in the direction of the same axis. Glide plane reflection is a reflection in a plane followed by a translational along a line in that plane. These are particular to crystals and the classification comes under what is known as a space group. In short, the point groups, there is at least one point mean center which is not altered. After all operations while in a space group, it is not possible to identify such a stationary point. Dear children, so now I am going to conclude that summary of the image. A group is a complete set of members which are related to each other by certain rules. Each member may be called an element. The basic properties of the groups are what? Certain rules have to be satisfied by the elements so that they form a group. The rules are listed below here. The product of any two elements and the square of any element must be element of a group. This property is the closure property. There must be one element in the group which commutes with every one element and leaves it unchanged. The associative law of multiplication should be valid. For every element, there must be a reciprocal, and this reciprocal is also an element of the group. Next, what are the rules is behind that? If A and B are the elements of the group, if AB is equal to C, yes, C must be a member of the group. Here, the product AB means that we perform the operation B first and then operation A. BA means doing A is first, then performing operations B is later. Means let BA is equal to D. D must be a member of the group. One rule, usually AB, BA also C and D. However, there may be some special elements A and B, each that AB is equal to BA, then A and B are said to be commutate with each other. The multiplications of A or B is commutative. Water belongs to the abelian group. The four symmetry operation H2 or what? Here E, C2Z, sigma V, XZ and sigma dash V, YZ. The interrelationship between these operations are given in the group multiplication table. Each group must necessarily have an element which commutes with every other element of the group, leaves it unchanged. Let n be the elements of the group, let x be the element satisfying the rule 2, xa is equal to ax is equal to a, and also bxb is equal to bx is equal to b. Here ba is equal to b x square a, b x square is equal to b, b, where x square is what? That is identity element. In rule 3, associative law of multiplication must be valued. This means ABCD is the same as ABCD. This is the form, associative law of multiplications. The inverse of element A is denoted by A inverse. It is simply an element of the group such as A inverse star A is equal to E. In case of symmetry groups, A inverse is that of element which undergoes annuals the effect of A. For water, we have, for example, C2 and C2 is equal to E, therefore C2 inverse is equal to E, that is C2 is its own inverse. This is true of all other elements of water, but this is not general. For example, here C2 6, here C3 2 1s are 3s are, here C3, that is not equal to E. Here C6 inverse is not C6. What is the order of a group? The total number of elements present in a group is known as order of a group. It is denoted by the symbol is N. The water molecule belongs to C2V group. Order is 4 because it contains 4 elements, namely E, C2Z, sigma V and sigma V dash. Ammonia belongs to C3V group of order 6. As it consists of 6 elements, namely E, C3 dash, C2, C3, 2, sigma V, 1, 2, 3. Abelian group. A group is said to be abelian if for all pairs of elements of the group, the binary combinations is commutative. That is, AB is equal to BC, BC is equal to CB, and so on. For example, the elements of C2 point group E, C2Z, sigma V dash, for an abelian group, has all the elements of these groups commutate with each other. Non-abelian group means a group is said to be non-abelian if the commutative law does not hold for the binary combinations of the elements of the group. Here AB is not equal to B. For example, the elements of C3V point group E, C3 dash, C3 twice, sigma V1, sigma V2, sigma 3 does not constitute an abelian group since the elements do not follow the commutative. The very important questions from these topics are: explain why set of numbers cannot form a group by the process of division. Explain the set of integers between 0 and mu do not form the process of multiplication. How to construct the table C3V considering ammonia as a water molecule. Draw the structure of 3 distinct isomers C2, H2, Cl2. Determine their point groups. Discuss the general properties of group. What are abelian and non-abelian group? What is meant by order of a group? Generating elements. What is meant by a subgroup? What is meant by classes? Write a note on group multiplication table, isomerism, similarity transformation, symmetry classifications of molecules and point group, the differences between point group and space group. Thank you.